Good morning, guys. It's Mr. Baya here, yours truly, one and only. Um, let's talk about how to multiply and divide rational expressions. So, as you recall, for a quick side note, when we're multiplying fractions, say for example, 3 over 4 times 1/2. Remember, as we've said many times, it's numerator times numerator, denominator times denominator, giving us 3/8, and if we can simplify, we can simplify. Okay? That's just a side note. So, when you're multiplying rational expressions, I remember rational expressions just a fancy word for fractions. So if I'm multiplying this, I'm going to take the numerator times the numerator, denominator times the denominator. So we're going to have 2a squared plus 16a all over 16a squared. Okay? Now, we can probably simplify this. However, I'm not going to be able to do anything yet because my numerator is written in terms of addition. So let's change it so that we have it written in terms of multiplication. If I factor out a 2a from the numerator, I'm left with a plus 8. And in the denominator, we have 16a squared. Now I don't see another a plus 8 here, which I can simplify that with, but I can do something about these two over here. 2a over 16a cancels out and we get 1 over 8a times a plus 8, which you can just rewrite as a plus 8 over 8a. Now, I'm hoping you better not think, oh, maybe the 8's cancel out. No, they don't. Or the a's probably cancel out. No, they do not. This is the best we can do. And that is our final answer. So let's go to a new part. What if we're dividing? Now, as you can recall, again, let's do a quick side note. Let's pick the same numbers as our side example from the previous one. Say we had 3/4 divided by 1/2, which I can rewrite as 3/4 all over 1/2. So I have a fraction. I have two fractions within one fraction. I don't like that. So to undo that, I am going to multiply by the reciprocal of the denominator. So cancel these out so they are 1. Multiply that by the reciprocal of the denominator. And then, oops. This gives us 6 over 4, which simplifies to 3/2. So basically, looking at that and that, when I'm dividing, I'm pretty much just multiplying by the reciprocal of what I'm dividing by. So let's apply that here. Now I'm going to do something different in this problem than I did with the previous one. Instead of multiplying first, so this will become 1 over x plus 4, and since I'm eventually going to be multiplying by the reciprocal, let's do that part now. X squared plus 6x plus 8 all over x squared plus 10x plus 16. Now I could sit here and distribute the x plus 4 to each term in this quadratic, but let's do something else. And this is something that you can also use when you're multiplying fractions. So what if instead we factored each one? By the way, notice this is now a multiplication problem, and I'm multiplying by the reciprocal of my original problem. So let's rewrite everything. But instead, let's factor out the second fraction. So instead of x squared plus 6x plus 8, you know what? I have OCD. Since I was writing the second one in blue, I have to write this one in blue. What multiplies to 8 but adds to 6? Plus 4 plus 2. And now let's factor the denominator. X and x plus 8 plus 2. So you're thinking, oh wow, I can actually cancel these out right now. And you are absolutely correct. What I'm going to do instead is I'm just going to combine these all to one fraction. So 1 times the numerator, it's just x plus 4, x plus 2. And in our denominator, we have all three of these terms, x plus 4, x plus 8, x plus 2. And again, you can do this when you're just multiplying rational expressions too. So what do we have here? I have an x plus 4 that cancels out, and an x plus 2 that cancels out. Leaving our final answer as up. There's nothing on top. Is that 0? Yes, it is. No, I'm just kidding. Hope you were able to correct me before I corrected you. And kill him. Boom. There's our final answer.